So welcome to our Enterprise Network Security and Automation class for this week. I do have the first 4 chapters up as far as, not chapters, they're not chapters, they're modules. I keep calling them chapters, but they're modules. First 4 modules up for of lectures on my YouTube page. I have not done the 5th yet. I'm going to go over a little bit of this today since it is due this week, but I'm going to discuss module 5. In particular, one of the things I want to do is that we are going to look at and have looked at what the basics are for access control lists. But this particular module looks at how do we apply them. And we're only going to look at 2 major types, standard and extended access lists. We've gone over those types in my module 4 lecture. This is how do you configure an access control list. And one of the things I always tell people, it's very important to know about access control lists, is that it's a 2-step process. First, you have to create the ACL, and then you have to apply it to an interface. And the big thing is, until you apply an ACL to an interface, it's having 0 impact on your router. It does nothing. So you can create all the ACLs you want, but until you apply it to an interface, and if you remember from the module 4 lecture, you can have 1 ACL per protocol, per port, per direction. And I always talk about, and a very confusing concept is, think about a person sitting in the center of that router. And that's where you look at in and out. That's always how you look at the direction. Don't think of anything else. Think of somebody sitting in the center of the router or device, because access control lists are also used on ASAs, adaptive security appliances. They're used, I call it the multi-tool of the iOS, because it's used for everything. They are used for controlling traffic. They're used for security. They're used for NAT. And we're going to get into NAT in module 6. We're going to learn that you have a NAT ACL that says what can and cannot be NATed. So they're used for everything. But a basic ACL that is used for security, once you create it, has no effect until you apply it to an interface. It's a very important concept. Are there any basic concepts on ACLs that you'd like for me to go back over?
I'm constantly getting confused on whether it's coming or going.
You really have to sit in the router itself and look at the interface and say, okay, if I'm sitting inside the router, out is anything egressing or leaving the router, and in is anything ingressing in an interface. So just look at the interface and then consider a person sitting in the center of the router. The other thing, don't forget too, is they all end with an implicit deny. So if you only put deny statements in your ACL, you're going to end up denying all traffic. So somewhere, if you're going to deny traffic, you're going to have a permit statement somewhere. Otherwise, your ACL will block all traffic. That's what they're designed to do by their implicit deny. The other thing that I want you to think about and that we talk about here is the concept of numbered versus named ACLs. There's very little difference. Actually, there's 0 difference in the way they work. It's just in how you create them. Numbered ACLs are 1 to 99 and 1,300, 1999. So if you need more than 99 standard ACLs, you can go up to 1,300 to 1999. There are a series of permit and deny statements. The very first item, the first access control entry that matches a packet, is the one that will take place on that packet. So be aware that the logic of your list design, your access control entry designs, is very important. Typically, we put our denies first, and then we have our permits. But that's not always the case. It's about 99% of the time, but not always. And with a standard ACL, it says access list number, if we're doing numbered, permit deny, source, that's the source IP, and the source wildcard mask. And that is because standard ACLs only filter using the source IP address. I call this the shotgun ACL. You kind of get in the ballpark. So you can't be extremely specific. It's just by the source IP. We'll also learn that because of this, we have to apply them as close to the destination as possible. Here we have a named ACL. So we can actually do IP access list standard, and this will make it a standard ACL. And then the name, and then you'll see here we have a new config mode you've never seen before. I call it the config standard NACL. So it's the standard network named access control list. So it's your standard NACL. And then it's just permit and deny statements. So the only difference between these two is the fact that one has a name and one has a number, and that's it. Once it's created, you have to apply it. So IP access group, the number or name, in and out. Again, create all you want, but if you don't apply it, you're not going to have an effect upon the router itself, an effect upon the router. So here's an example. This is assuming that only PC1 is allowed to get to the internet. All right, so we're going to create a standard ACL to allow only that one host to get out. So we'll go in here and we're going to remark it. Now, one of the things I talk about in this chapter is to add remarks to every access control entry statement. I'm torn about that. Yes, I do want you remarking your access control list. I tell my students this. The problem is, let's imagine an ACL that's got 50 entries in it. If you remark every single one of those entries, now you got a 100-line ACL that I've got to wade through. Personally, I would rather take that ACL, store it somewhere in our network database, and have all the remarks there. And then when you dump it in, change it to where, okay, remark, allowing servers access to data center, and then have all the entries for that. And then remark, this allows whatever, you know. So I wouldn't remark every single access control entry personally. I would do it in sections, you know, as much as possible. And sometimes your logic won't allow you to do that, but I just think that when you get, you know, a remark for every single entry, that's a pain. Now, if it's only 2 or 3 entries in your access control like this one, that's fine. That'll work. But so here we've got access list 10 remark, allow this host access the internet. Access list 10 permit host 192.168.10.10, which is, remember, the same as saying 0000. So host simply replaces putting in quad zeros in the wildcard mask. All right, that's that particular keyword. Now, at this point, a lot of people say, okay, I've created my access list. Well, whoop-de-doo, okay, because you've created it, but until we go out here and apply it on the serial interface, it's going to have 0 effect on the router. So creation of the ACL does not mean that it's going to do anything. I need to probably pause that. That's going to do anything. So here we have access list, remark, permit, do show access list, and see here we've got our, we've actually added another thing here. So we've enabling a policy to allow LAN 2 to also have internet access. So we've got that. You'll notice something else. You notice that each one of these has a statement, or it's a sequence number. I call it a sequence number, but it's a line number and an ACE entry number. These are important later because it's how we will be able to go in and change individual ACE entries without having to completely remove the list. Used to be we had to remove the list completely, rewrite the list, and then put it back in. Now with these entry numbers, we can actually change the ACE entry. We'll talk about that when we get to the modifying section. But here we go. We're going to put it into IP, or interface serial 010, IP access group 10 out. And again, looking, we're sitting in the router and it's out. Now, the rule for standard is put it as close to the destination as possible. Well, this is as close as we can get because we have not been able, we don't have control of anything on the internet. So an outbound going here. Just think about this. If you tried to put it as an inbound on gig 000, host 1010 wouldn't be able to get to LAN 2. Actually, host 1010 would be the only thing to be able to get to LAN 2. Nothing else would be able to get over there. Because our access list is to permit only host 1010. So if I made a mistake and put it as an inbound on gig 000 and host 192.168.10.11 tried to access LAN 2, it would be blocked because what's at the end of the access list? An implicit denial. So that's why we had to put it out here. Much better access list would be a standard access list that would allow us to do some things a little bit different here, differently. But this would work, okay? And then we can also do a show IP interface and see which access list has been set. And I'll be honest with you, other than show run, section access list, other than show run, the only way to see if there is an access list applied on an interface is with the show IP interface command. So show access list shows you our list. Show IP interface shows you the access lists that have been set on that interface. Now we can do the exact same thing with a named list. So no access list 10, we remove it. By the way, if you've left an access list on an interface and you remove that access list, it depends on the iOS version as to what the behavior will be. So in other words, let's imagine that I did this no access list 10, but forgot to take the access group command off of 0010. Previous versions of the iOS, it would allow all traffic. Okay, so in other words, it would just say that access list doesn't exist, so I'm just going to allow everything. Current versions, and I've got to test this on this one, but on even on the XE version, I'm pretty sure current version, the result is to block all traffic. So in other words, it says the access list is not here. You've applied an access list to an interface and there's no access list in the config, or there's no existing access list. So we're just going to block all traffic till you fix the problem, which is probably a better way because that defaults to closed instead of default to open, which is two different ways of doing security. So not only would you need to remove the access list itself, but you'd also need to remove the access list that's been applied to the interface. So let's just assume we do that too. We've already done that. We're going to create a new one, IP access list standard permit access. Okay, so we give it a name. Standard NACL, we're in here, we're putting in our remark, we're putting in our permit statement. By the way, some people do also put in the deny statement. So they put in deny any. Just even though it's there, it's implicit, so they see it. It's not going to hurt anything, but some people do it. You know, that's personal preference. Then you go down and you, we're also going to allow LAN host 2. So we're going to permit 192.168.20.0 and then 0.0.0.255, which allows anything on the 192.168.20 network. Again, I mentioned this in the module, but wildcards in access control list are only really significant as they are compared to the IP address in front of the wildcard mask. All right. And then we're going to apply it. IP access group permit access out. Now make sure, here's a key thing. This is a Linux-based kernel. So if you made the name all caps, then when you apply it, it must be all caps. Otherwise, you are applying a non-existent access control list. I've seen that happen so many times. So people will create the access list and they'll do a capital P, capital A, and everything lowercase. And then they'll go apply it. And when they apply it, they use all lowercase. Well, you just applied a non-existent access control list. So make sure the name that you give it is exactly the same as what you apply to the interface. You can do your show access list, you can do your show IP interface, and you will see that it has been applied to that particular interface. So standard ACLs, very simple. Filter based upon the source IP address. Place them as close to the destination as possible. Okay, any questions on those? They're very, very simple. So let's look at modifying an ACL. There are two ways to do it. One is totally remove the ACL and rebuild it using a text editor. So in other words, a lot of people keep a list of standard access control lists that they've used, and they just keep them in a Word document or a text, well, text hopefully, because Word throws stuff in. They keep it in a text document. And when they need to change an access control list, they'll copy out the existing access control list, dump it into a Word document, excuse me, a Notepad document, and then make changes and dump it back in. So Notepad++ or whatever. So here, for instance, you'll see that we messed up and we accidentally put denial 19.168.10.10 instead of denial 192. Well, one way to fix that is just do a no access list 1 and put the 2 statements back in correctly. Okay, so that's one way. Another way is with sequence numbers, which is a little nicer. So you've got here show access list, you got a standard access list 1. You can go ahead and say IP access list standard 1. You see that this is sequence number 10. So that's the ACE, the access control entry we need to change. So go in here and say no 10, and that will get rid of 10. Then we can put in 10, deny host 192.168.10.10, and then that will be placed into the ACL at that position. By the way, you can use 10, 11, 12, 13, up to 19. And by default, the sequence number, there's 10. It's 10 spaces between each access control entry. There's actually a command, and off the top of my head, I can't remember. You can do a Google it if you want to, but there's a command to change the number of sequence numbers. You can actually put in your own sequence numbers if you want to. You can put in numbers beforehand. But by default, it's 10. So you can change one if you made a mistake. And then again, by default, each one is 10 places apart. So it'd be every entry would be 10, 20, 30, 40 on down, depending on how many entries you had. Same thing with a named ACL. You go and do the exact same thing. Here's an example of adding an additional access control entry in instead of removing one. So we've got the right entries here. We've got deny 192.168.10.10, so there's no problem there. But we'd like to add a deny entry between these two, because this permits all hosts. If I just add it, if I just put in the entry, deny 192.168.10.11, by default, it would have gone in as entry number 30. Now at that point, it wouldn't have had any effect, because as the packet drops down through, the ACL, the first thing that would be applied would be, is this 192.168.10.10? The answer would be no. The next answer would be, does it match 192.168.10. anything? Well, since it's from 10.11, the answer is yes, so it would be permitted. At that point, the packet would never make it to entry 30, which was trying to deny 10.11. So to fix this, we have to go in here and we can put in an additional entry, and we say 15 deny 192.168.10.5. In this case, I did 10.5, and that would go in here. And what will actually happen eventually is it will, when the router's saved and reloaded or even saved, it will actually put it in order to be 10, 15, 20. And then there's even a way, quite honestly, if you make a mistake, depending on the iOS version, but if you make a logic mistake, in other words, if you're putting in entries and you put in a deny after a permit, it will tell you, hey, you just made a logic error. You've already allowed this up here. You want to move this up? And it will actually move it up. Will prompt you to move it up in the sequence numbers. So
they give an explanation there that I find kind of confusing.
What's that?
Of what you were just talking about. Expect the order of the statements.
Function?
Yes, I'm not really following what those last two sentences are. The resulting order optimizes the search for a host ACL entry, and then it searches for range statements. So I'm not clear what it's actually doing. But if it'll resort it into 10, 15, 20, that makes sense to me. But what they put there doesn't really make sense to me.
Well, and here's something else that's even more confusing that gets a little wild. We don't talk a lot about it in the CCNA, but you know what Cisco Express Forwarding is? CF. So in other words, you route once. Well, actually, before you ever route, you create a forwarding information base of all possible things that need to be routed, and you have that already in existence. So Ceph, what it does is it looks at all the possible destinations in the routing table and builds a fib or forwarding information base to say anything that needs to go to here, 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 go there. The iOS actually does the same thing with access control lists. So in other words, while we think that literally every packet goes through every single little, and it does, it goes through every single thing, but there's a way for the iOS to, try to think of the right way to put it. The iOS builds for lack of a better word, it is a table, but it builds a table of the most optimized access control entries, and then uses that regardless of what you've got in your ACL. So it won't change the logic, but it will attempt to change the way things are applied. Now, I'll have to be honest with you, this is more on the ASA side, but I know on the ASA side, it can even get to where it would move an entry that is hit more often than another one up into this logic. So it would look at the statistics and how things are. So, you know, if we're denying 10.5 more often than we're denying 10.10, it would literally, even though if that was ACE 15, in the logic of the hashing, it would bring it up in that ACL so that, you know, it makes no sense to go through 30 statements, 30 ACEs, and then deny something. If that traffic is the most common traffic being denied. So it will actually try to do that. The other thing it will try to do is it will try to, and the hashing function gets down to trying to take the entries that would be permitted or denied most often and move them up the furthest. And that's, I think, David, that's what it's talking about. I'll try to find some other reading on it, but it's basically, it will try to optimize the access control list based upon your entries and upon, depending on the iOS and on the device. You can even do it based upon the amount of traffic that goes through that particular ACL. So
Thanks.
So here we see access list counters, so standard ACLs, and this is where we've done where we're getting matches. I use this most often when I'm trying to do NAT, because if I do when we get into NAT in module 5 or 6, one of the things is show IP NAT trans. Well, if I'm getting no translations, a lot of times I'll go look into a show access list to see if it's hitting my access list, because I may have just screwed up the ACL, the NAT ACL. We'll talk more about that as we move into the NAT ACLs. Here's part of that Swiss Army knife philosophy, controlling access to the V2Y lines. So we could say our management network is, let's say it's, for whatever reason, it's the host 1010 is our only management host, which I wouldn't have just one management host, but that's the example they're using. So let's imagine that only host 1010 is our management host. So we're going to go in here and we're going to do username, admin, secret class. We're going to create a standard ACL called admin host and permit only host 1010. Deny everybody else. Okay. Now, of course, it would have a denial already, but that's okay. We can put it in there. Line V2I04, login local, transport input telnet. Never do that. Never, ever use telnet. Okay. There should be transport input SSH, not telnet. But this access class is a different type of command to apply the standard ACL to the V2I line. And it's the only place you'll use the access class command. So access class admin host in. At this point, only this one host could access the V2I lines on this router. And again, you should be doing crypto key generate RSA, and you should be using SSH here. All right. And there's where they're doing transport input SSH. So I wish they wouldn't even have this in here. That's insane. Don't even show people stuff you're not supposed to do. But this would set it up. Now, typically what we would see instead of a single host in the real world is you're going to see this be a management network. 192.168.10.0, 000.255, or whatever your management network is. 99.0, 200. Whatever. But if you wanted to, you could make it a single host or a single set of hosts. And then when you get it, if you try to connect and you're from anything other than the IP address that is allowed, you'll get a connection refused. And you'll be able to go in here and see that there was deny. And that's one of the reasons they put the deny statement in here, is so you can actually see the matches on this. If you don't have the deny statement in, you won't see matches because it's an implicit deny. But by putting in this deny any, it lets them see it lets you see any matches that occur on that ACE. Still a standard NACL. Okay, so still everything's being controlled by source IP address. So if it comes in from this, by the way, if you can spoof 192.168.10.10, you're going to be able to get in, or you're going to be able to connect, okay? You'll still need to know the username and password. But all this is doing is basic, security. Here's where you get yourself in trouble. You only allow 1010, and I, as a hacker, figure this out, and I do a denial of service against 1010. And then at that point, you can't get into your network because that's the only host that's allowed to get into your devices. So you had to be real careful. It's almost like the perpetual discussion of locking out accounts when they fail username password. The used to be when I first started in this business, after 3 attempts, you're going to lock them out, and you're going to lock them out forever because you want the admin to have to unlock it. Well, guess what? All you had to do at that point was write a script to try every username, which everybody knows is the first part of your email address. Duh. Okay. So you try that and use invalid passwords, and I can lock your entire network out permanently. And then guess what? Your admin's going to have a really, really bad day because they're going to have to sit there and try to unlock 40,000 accounts, depending on how big you are. So now, extended ACLs, they also are numbered and unnumbered, but they are able to use both source and destination IP address, protocol, port, all types of things. This is what I call the rifle version of an ACL. In other words, you can get dead on target with it. If you want to block this host from this host using TCP on some weird port, you can do it. All right, so you've got complete control here. And in fact, these are more useful in the real world because of that. So we've got access lists, our number, which is by default 100 to 199 or 2000 to 2699. You may see that somewhere, just saying. Those numbers you would see somewhere. There's still permit deny statements, folks. Okay, so that's no different. Still a series of access control entries that are permit and deny. There's a protocol, there's a source wildcard, operator, destination wildcard. And a lot of these, there's a lot of things in here we don't necessarily always use, but you can get extremely specific. So in other words, in the operators, you can say ports greater than or equal to, less than, not equal to, range. So you can do all kinds of crazy stuff with extended ACLs. This is the establish command. If you do this with TCP, it pretty much creates what we call poor man's stateful firewall. So in other words, the way TCP works, you've got a SYN and a SYNAC. Well, if a SYN originates on the inside and you get a SYNAC back, and then you get an ACK, you have an established TCP connection. So what you can set up is a basic ACL rule that says, allow this traffic with TCP to go out, and then if you get a 3-way handshake, allow established traffic back in. And we'll show you an example of that here shortly. But here's all kind of protocol options. So it could be DVM, MRP, it could be EIGRP, GRE. We see this a lot of times, especially with ESP and AH. Those are a lot of times we have to allow those to be able to set up our VPN tunnels, but all different types of stuff. And then you also have port keywords. So you can do, either BGP or you can do 179, TCP 179. So this says permit TCP from any source. And remember, that's quad 0, quad 255 to any destination, quad 0, quad 255 equal. And you can set any of these. So you can see there's all kinds of crazy stuff here. That's not really that crazy. It's just protocols that are supported by TCP. You can change this to UDP and do a question mark, and all the UDP protocols would be listed here. So here's an example of access list permit TCP from any host, any source to any destination that is web, or you can write it like this. You can write it either way. Okay, they're exactly the same. This would be SSH, and this would be HTTPS. And then, just like any other access control list, you have to apply it. So we're going to do access list 110 permit TCP from the 10.0 network, anybody www, and also allow HTTPS. So we're going to allow HTTP and HTTPS. We're going to go to gig 000 and do N. Now this is because you put extended ACLs as close to the source as possible. Now notice, what's going to be the effect on the LAN 1 network once I apply this ACL? Will you be able to ping from LAN 1 to LAN 2?
No.
Steven says no, that's correct. Because the only thing you're allowing is you're allowing the 10.0 network to go to any other destination with web or HTTP and HTTPS. In fact, the 10 network here will be able to access nothing but web traffic on other networks.
Now, is web traffic defined as port 80?
Port 80, yes.
Yes.
EQ www is the exact same thing as 80.
What does the EQ stand for?
Equal.
Equal. Okay, my bad.
Yep, equal. Yeah. So permit TCP from this network to any equal 80. So anything going out to www. But remember, it's still inbound because it's coming into the router this way. So the source is down here and it's coming into the router. So there's a person sitting in R1 looking at the traffic. That's how you decide to in and out. Now, here's the established, what we talk about, TCP request from PC1 to the outside public network is permitted. The reply traffic is allowed only if it originated on the inside network. So if we look down here, we do access list 120, permit TCP any, established. Okay, so this is any, so any source to this destination established. You'll notice that it's going to be on gig 000 out that we're putting 120. So we had 110. Let's go back up here real quick. We've already put 110 as an inbound list. So traffic coming from here going this way is using the 110 list. So it can go out and connect to anything with HTTP or HTTPS. If traffic comes back established, in other words, we've got a send, SYNAC, and ACK, we'll allow that to come back in. That's why we call it a poor man's stateful firewall. Okay, because really it's only looking at it really isn't keeping up with the full state. It's just looking at, did it originate on the inside and does it have an established TCP connection? And folks, I'm not going to spend a lot of time on named. It's the exact same thing named. Just give it a name. Key, again, here's the key. Make sure whatever you name it is the exact same name you use to apply it to the interface. Case sensitivity matters. That's why some people say use all caps. Some people say not use all caps. I just say have a consistent, do it consistently, whatever you do. Editing extended ACLs, same thing. You can just change the sequence numbers. So you can do that, say no 10, and you can change it. Let's say you messed up and accidentally put 19 instead of 192. Well, you can just go into the list surfing. By the way, this is now an extended NACL, extended named access control list. So the only difference you're going to see here is that. Still a series of permit and deny statements, but we can do no 10 and then put the new 10 in and we would get it, it would change it. Okay. I'm not going to go over these. I'll let you look at those as we move forward because I want to spend a few minutes going over something I promised to talk to you about last week. Inside, Cisco now has a new tool, which honestly I don't think has a, I'm not convinced it has a great deal of use. By the way, that's not PAP's Blue Ribbon. It's Plan, Build, Run. I actually got that at Cisco Live last year. It's one of the coolest shirts you could get there. Looks like PAP's Blue Ribbon, but it's not. But they have a new tool called Cisco Modeling Labs. It used to be Viral. They've changed the name, obviously, because viruses don't really have a great connotation right now. So they call it Cisco Modeling Labs. And in fact, it used to be called Cisco Modeling Labs at the enterprise level anyway. But there's a new tool called Cisco Modeling Labs. And it is much easier than it used to be. Back when it was viral, it was a very big pain in the butt to run. But it now comes, when you buy it, you have to download 2 fairly large files. I won't try to go find them, but basically it's one file that's the OVA for the CML, and that will run inside of Workstation. So here's the CML for x86 64-bit processors. You got to go through a little process to install it, set some passwords, those things. It's very simple. I mean, it's a 10-minute process. It's a 4-hour, 5-hour process for me to download it on my super slow internet connection, but the setup itself is fairly easy. You then have to set up, one thing that's a little weird is you then have to download this huge, and I do mean huge, file. And in this case, you'll see that it is called the Reference Platform File ISO. This ISO contains all of the iOS images for the virtual iOSs that run inside of Cisco Modeling Labs. All right. So you got to do a couple of little things, but basically you boot it up. At that point, you get, it boots up, takes a little bit, and you get an IP address. So this is 192.168.254.89, which is on my local network. So this is just bridged over to my local network. You then go into a web page and you log in. So I can log out, okay, and basically just log in with admin and whatever your password is that you set. And at this point, you'll see, obviously, these items here, CPU load. By the way, you need at least 16 gigs of RAM. And this machine is a 16 gigs with multiple, let's say I got an i7. So this is a gaming PC. So this is a pretty honking PC. Need more RAM, but it is what it is. But you can then create different, what they call workspaces or labs. And if you look in here, I recreated pretty much the enterprise network security automation skills-based assessment. So in other words, I probably shouldn't be showing you all this, but all right, so here's what skills-based assessment is going to look like, at least in part. It's going to be 2 routers. There's going to be 2 switches. Now, in the switches, you'll notice it's an IOSV. So I'm going to go over here to Lab Manager just real quick and add a lab so I can show you. Okay, so I'm going to go into the lab. So I have to move you all over here, but you'll see I've got all different types of things. I have an NXOS, I have an NXOS 9000, unmanaged switch. Here's iOS V2 or VL2, so that's the layer 2 switch, iOS. Here's the 1000V, which is a Cisco router. There's all types of different things here. There's desktops. There's an Ubuntu desktop. There's even ways to connect to real gear externally. So it's kind of like the packet tracer ability to do multi-user if you've never ever used that. That's something we don't use a whole lot anymore. But so there's all kind of things you can do here. I'm gonna go back out for a second because I want to show you my lab I built. So this is an IOSV, so it's a router, and I can actually just click start, and now it's starting up. And in fact, I could go back out to Lab Manager and start all the entire lab at one time. So I just drug these over, and so now I've got a lab. Now it's very similar to the way you do Cisco in terms of the packet tracer. I do have different, in fact, I've took IOSV layer 2, and I connected gig 00 or 01 to 01 and 02 to 02 between these two. The negative is, we look in here and open the console, when this thing starts booting, which it will eventually. It does take a while to boot. It is a little slow unless you've got a ton of resources to throw at it. You can see that things are booting here. You'll see that the desktops have actually booted. This is something that's pretty cool. These desktops, if you go to VNC, you'll see they're actually little Alpine Linux boxes. So it's a little Linux box sitting here. I haven't figured out how to connect them to And my goal is to eventually get them connected to a Windows 10 virtual machine that's running on a machine also. I hadn't figured out how to do that yet. I'll get there. The other negative here is if you want to change IP addresses, you have to use the, you know, right now, it's just got a no IP address on it. You have to do the if config. So imagine it's, let's put in 192.168.12.10, net mask 255.255.255.0. You got to do a sudo and then ask you for the password. And on these, oh, forgot to do it, ETH0. Golly. Can't type. ETH0. All right. Now you'll do, if I do an if config, you'll see that it's got 192.168.12.10. You also have to set the default gateway. So you'd have to go in and set the default gateway if you want it to be able to get out through the router. Let me do this. I'm going to move this down just a tinge. You'll see the devices have now booted. So if I go to this router and I go to the console and open it, you'll see here's a Cisco router. And unlike GNS3, which is illegal, this is a legal version of the virtualized iOS, completely legal. It is, there are some negatives here. I'm in the iOS. This is the switch. So I do a config T and I say hostname S1. Okay. If I wanted to create a trunk between these two, the thing that's weird is this is an older iOS version, L2 iOS, which means it supports both ISL and it supports .1Q trunking. So if you're like me and you're old school, you can figure out the older commands because there's a couple older commands that apply. But for the most part, I've been able to do everything on the final that you're going to have to do in this lab with just a few minor changes. So nothing major change. Like I said, you'll notice supports do show ver. I mean, it's full iOS version 15.2. Okay, so I mean it's K9. It's, you know, it works. It works well. Again, the hosts are a little funky, but that is what it is. Here's the router. By the way, the router I've had no problems with. I've been able to make everything on the routers work. The other thing that's kind of cool, quite honestly, is this supports up to 20 nodes, which means that, I'm going to show my stupidity because I don't know how to add another. You can force wipe it. You can do other stuff. Go back to my lab manager. So I could literally drag out 20 routers and create, you know, a multi-area OSPF setup. Now, when you go to connect them, you click on the connection link here and drag over, and it tells you, you know, and here's the other thing, you see all the interfaces. So gig 0 to gig 0, and it does it. So there's gig 01 to gig 01, and then here, same thing. So there's some pretty cool features to this. Does it have limitations? Yes, of course it does. The major limitation is it costs $200 per license. Okay.
For just 1 year.
For 1 year, correct. Yeah. Yep, 1 year. So it is a yearly license. It is not, you know, it's not the cheapest thing on the planet, but I do think it has its place in some areas. I do like the fact too that this, quite honestly, when you go to take your CCIE, this is what they're running in the background for you to do your CCIE. I mean, it has to be. They're using the professional version, not the Cisco. And by the way, if you look, there's two versions. There's a CML Personal and there's a CML Enterprise. They're running. You don't get tax support with CML Personal. It still allows 20 nodes. You can't expand the number of nodes. You only can have 20 nodes. But if you buy the Enterprise version, you can do up to 300 nodes. I don't know the cost on the Enterprise version. It always scares me when they don't give a price on anything. That pretty much tells you it's going to be expensive. But, you know, that you can buy it. It used to be in the tens of thousands of dollars. It used to be for enterprise version. It was in the $20,000 to $30,000 range to buy enterprise. I don't know if that's still the case. The other thing I'm thinking about playing with is, obviously I've got this running on a local machine, but I'm thinking about buying or taking my license and transferring it to an ESXi host, and then trying to put a NetLabs pod in front of it and see if that would work. Now, legally, I don't know if I can provide multiple people to have access to it. But I would think if I would buy a license per pod, the only negative is I then had to go in and build every single lab. But you could actually do that. You could literally go in the lab manager, and let's say that, your first lab is a single switch and 2 hosts, or a host and a single switch. Well, you can do that. I mean, you can actually go in here and pull out and have that. Let me get rid of the iPod. I meant to get a desktop. There's a way to change the number of even the number of interfaces on it. Oh, there it was. Delete node. So I can pull out a desktop. So if you had a single, one PC going to this, you'll notice there's only, by default, there's only 3 interfaces. You can put more on it, but that's it. And so now we've got a switch and we got a single PC. The other thing I don't know how to do yet, quite honestly, is I don't know, there's no way to actually do like a console connection. You're just going to click on the device and you're going to go to the console, and you'll see that device there. So, but I think there's some possibilities with this. I especially think in the CCNP range, I think this has some possibility. And I've got to play with it some more because, again, there's all kind of different iOSs on here.
Do you think Cisco is going to push this over, like, say, the NDG pod model?
I don't know. I have been trying, honestly, and I know it's being recorded, and I'll say it on tape. I've been trying for 2 years to get Cisco to give me the iOS-Bs, because I told them, if you gave me the iOS-Bs and I could build pods with those using custom pods from NDG, I could probably provide lab support for every single school I support for $35 a student. Because if I didn't have to have real physical gear, if I had the virtual iOS and I could boot up pods and all I had to do was throw servers at it, I could support an enormous number of students on my data center. So this may be a route I can go. It may be even that I would think of going and buying an enterprise license and then sharing that cost out across everybody. I got to do a lot more work with it to be comfortable saying that, because it's got a lot of, just like the fact that you don't have a Windows 10 box. When I go in here, I don't mind going in and doing the sudo and I don't think this thing's booted, hadn't booted yet, still booted. I don't mind doing that. Simulate it. It's trying to load. But at the same time, the problem I have is, it's not Windows 10, so it's not going to match the lab exactly. So I'd have to have instructors who are willing to know that it doesn't match the lab exactly. And as soon as that happens, all kind of things can blow up. You'd be amazed. In NetLabs, it says, this lab has been modified for the NetLabs environment. You'd be amazed the number of emails I get saying, it's not working. And I'm like, well, what lab document are you using? I'm using the, no, it's not it. You got to use one inside of NetLabs. So there's some definite issues here, but I think they can be overcome. A big problem, like see, look here, just for me locally, with just two pods running, actually 3 pods running, we've got some resource issues. But I throw this on a big honking server, I'm not gonna have an issue. I put this on one of my Lenovo or Dell servers that are, got 256 gigs of RAM and more cores than you can shake a stick at, and I'm not gonna have an issue. especially if I can push it across, if I can make it to where it boots up individual pods and I can spread them across different servers. So my hope is that Cisco will either give us access to the iOS, and this is what's stopping me, by the way, this switch. I've got the 1000V, which I'm comfortable with the 1000V, that I could do anything in routing that we need to do in the CCNA. But if I don't have a layer 2 iOS image, I'm dead in the water. Because without a switch, you know, and this is, you know, it's a layer 2 switch. And it does, like I said, it has some quirks. But even here, you know, do a show IPM brief, and you'll notice there's only 4 interfaces. So I could literally, if I knew that it was going to be legal for me to use this, I could go get the template for NetLabs, and I could change all the labs to fit this environment. It wouldn't be easy, but it's possible. You know, at that point, we look at trying to lease out our system to people.
Yeah.
I don't want to lease things. I've always said, and I've done this for years, it's before we went to move our programs online, I said, I'm not going to move online unless the seated and the online student can get the same lab experience as close as possible.
Kelly, what we're doing, we're going forward with the Net Labs at our school.
Yep.
And it's really, I was surprised at how inexpensive it really is now. I mean,
really
because
is
we
not
already
bad.
had the data center.
Yeah. If you've got the data center already, if
Right.
you've got space in your data center and you've got some servers, it's not cheap. I mean, let's be honest. You're looking at 20 grand for a base. Well, is it 10 grand now for a AE license? So I think it's 10 grand for an AE license. You're looking at 50 grand probably.
That's what it costs us.
Yeah, about 50 grand to put a system in.
Yep.
You know, with 50 grand, I can buy a good number of Dell servers.
Yeah.
You know, and then if I had NetLabs in front of that, you know, and I don't have to have the physical space to put the equipment, I could really get kind of crazy. But yeah, the NetLabs is, I hadn't found anything better in terms of being able to share your resources faster, easier. There, you can do all kind of crazy stuff. I mean, that you can put in your own remote telnet stuff, and you can SSH in and then remote. That's possible, and you can do that for about $5,000. But then you have no scheduler, you have no ability to see what your students have done.
But for the whole program, that's not bad. I mean, I guess if it were a smaller school, but that's not bad for a whole program.
No, it's not. It's not. And folks, I'm gonna do something. I'm gonna go ahead and, you have any other questions? I'm gonna stop the recording in a second.